All right, listen up. Okay, this is trigonometry. For you people that are actually paying attention, I am excluding a group in the back over there. Okay, so now I'm going to show you guys this problem. I accidentally, when I copied this, I copied all the steps too. But I'm going to show you guys right here. So this is cosine of 180 minus theta. So cosine of 180 minus theta, right?
Sure.
Say yes.
Yes.
Okay, so theta is some unknown value, right?
Yeah.
Okay, so what we're going to do is, we're going to go through and actually find what I can get from this from the information I know. So I'm going to use, this is going to be the difference formula here. So it's going to be the cosine of 180, cosine of theta, and then plus sign, sine of 180, sine of theta. Now, from my unit circle, because I know everyone's got their unit circle in front of them right now. Everyone's got it in front of them right now. So, cosine at 180 is?
Negative 1.
And times cosine of theta. What is sine at 180?
0.
Times sine.
That's a line.
No, I hate it when it does that.
Sine is a line.
Sine of theta. Anything times 0 is?
0.
So that piece goes away, right? So my answer is going to be negative cosine theta. Is that like super easy there?
Yeah. Well, I'm still copying it down.
Okay.
So I was paying attention.
Okay. Who might I call you a liar?
Copy the white.
I was told I'm supposed to be more sassy with this class because, you know, I'm not as sassy with my classes this year as it was last year. I gotta be more sarcasm. I know it was you, so all right. Anyway, I'm sassy and I know it. All right. Okay, so this right here. Again, this is all done, and remember, like everything in this class, there's one way of doing it, then there's my way. Okay, which way's right?
My way.
Yeah, my way is actually a whole lot easier. So, you guys are going to help me, and I'm going to copy down, wow, not all that, oh god, that's ugly. Alright, so insert, page, after. Okay, so what was given to me? So help me with this. So it said sine. Did it say sine?
Yes.
So it said sine of S,
Equals 3 over 5.
and it also said cosine of equals,
Negative
12 over 13.
and what am I trying to solve with that?
Find
Cosine
Okay, find cosine S plus T. So it's basically, I'm adding two angles together, and this is the end result already. So I got to try and figure out what it comes out to be. So, for what I'm doing right here, class,
Yeah.
what is sine?
Y.
Over?
1.
Now, in this case right here, is this an identity? Say no. It's not an identity. Identity would be just like sine theta or cosine or of that, where I'm actually just simplifying. But this one, sine, I actually have a fraction, right? So I have numbers to go along with this. So this is going to be, sine is going to be y over r. Yes? Good. So for this first one, I have, for S, my y value is, my x value is,
Oh, we don't know.
and then r value is.
5.
Have we done this already?
Yes.
We have done this. And I'm going to go back a page. And it says sine, and both S and T are in quadrant 2. Okay, so they're both in quadrant 2. So in quadrant 2, so I'm going to sketch my quadrant 2's over here. So right here it's a negative and a positive, right? So what do we know about x in quadrant 2?
Negative.
It's negative. Very good. So that's a negative. So I know I'm going to start there. All right. So how do I find my missing x? Pythagorean theorem, right? X squared plus what is that going to be?
3 squared.
3 squared is equal to?
5 squared.
You guys remember this now?
Yeah, multiply that plus that.
So it's going to be x squared is equal to 25 minus 9 is 16. X equals, take the square root of both sides, plus or minus 4.
It can be minus.
It's going to be minus because we said this one is in quadrant 2. So it's a negative 4 here, right? So there's my S. So my S, I have all those. Okay? Now we got to do the same thing with the T's. So I'm going to even change color on this just for this. All right? Make this special. All right. Class.
Yes.
Cosine is what over what?
X over 1.
X over
X over R.
R. Why is this one R?
Oh, wait.
I'm dealing with numbers again, right?
Yeah.
Identities are the ones that are always over 1. But since I'm dealing with numbers again, it's x over r, right?
Yes.
Normally with identities, it would still be x over r. But what is the radius of my unit circle?
Always 1.
It's always 1. So that's the reason why my r would always be 1 in those cases. So this is x over r. So my x value is?
Negative.
My y is?
We don't know that.
I don't know. Then r is?
13.
Again, Pythagorean theorem, right?
Yes.
So let's plug in what we got. So we have negative 12 squared plus y squared equals 13 squared.
144 plus y squared equals 169.
Yes, 144 plus y squared, 169. So y squared is equal to 25. Y equals plus or minus 5. Right?
Yeah.
So plus or minus. So tell me, in quadrant 2, what's my answer?
Plus.
Positive. It's going to be a positive 5, right?
Yeah.
Okay, so I'm going to put in a positive 5 right here. So is there any questions of what I did right here?
No. You basically did stuff that we already learned.
Yes, so I turned this whole thing into something we've already done to be able to do this now, right?
Yes.
So now I want you guys to pay close attention to your x, y's, and r's, okay? I need to find cosine of s plus t, right? So I'm going to insert a new page here because my other one is already filled out. So it's going to be the cosine of s plus t. Now let's fill out my formula now, right?
Yes.
If I fill out my formula, it's going to be the cosine of s, cosine of t. What goes next?
Minus.
Minus sine of s, sine of t. All right. Now, remember I told you, pay attention to your x, y's, and r's. So, cosine of s. What was it?
It was negative 4 over 5, wasn't it?
Negative 4 over 5. Let's look. I'll back it up. Here's my s's, right?
Yeah.
My s's was negative 4 over 5. There we go. Times. What is cosine of t?
Negative 12, 3,
12 over?
13. 12.
Very good. Minus. What is sine of s?
3 over 5.
Positive 3 over 5. What is sine of t?
5 over 13.
5 over 13.
Wait, that's a big number.
Not really.
No. You multiply it still, right?
So negative, negative, positive 48 over 5 times 13 is 65 minus 15 over 65. Now, let's do the math. 48 minus 15 is going to give me 33 over 65.
That's it. Oh, that's easy.
So I want to show you guys the difference of what I do to the way that the notes show it. So right here, going through, use all this. Okay, here's our stuff.
All the answers are right there.
Okay, here it is again. Okay, go through, do the work. They get the same thing. They just end up doing a lot more work. Okay, here's another way of doing it.
Oh, no.
This one is not very nice.
It looks nice.
No, it's not. It's nasty. Alright, so this one right here, it's not as easy. And you have to fully understand it to know where it's going to be. So it does not come out very good.
Why do you have a choice? Why do you have a choice? The next slide.
A story?
No, choice.
Source. Source at the bottom.
No, this is from where he got it from that have the source. Like he didn't write it himself.
Are you talking about this right here?
Yeah.
Oh, yeah. So this is actually just their example. Okay, I don't know. This is real world math here. This is how stuff is actually applied.
But nobody looks at that.
1980.
Apparently you just did.
Because it's not story.
You just did.
Because it's not story.
You did.
You just,
That was you.
Oh,
yeah, you don't.
You just said who and it was you.
I'm a nobody. So I said nobody.
Okay. Yeah, thank you.
Wow.
All right. Household electric current is called alternating current because it is a current alternating direction within the wires. The voltage V is a typical 115 volt outlet, can be expressed by the function volt of T is going to be equal to 163 times the sine of WT, where W is the angular speed. Do you remember angular speed? Radians per second. Okay, of the rotating generator at the electrical plant, and T is a time measured in seconds. So we're just basically plugging in numbers. Plug in numbers. Okay, like disregard. Okay, essentially, for electricity generators rotate precisely 60 cycles per second. So that's what we get right here. So 60 cycles, one cycle is like one rotation, right?
Yes, 2 pi.
So times 2 pi, so my rotational speed is 120 pi.
Per second.
Yes. So the formula, okay, it's going to be 163 sine of 120, crap,
Pretty good too.
120 pi
2.
times t, right?
You're gonna 162.
What is it, what?
162.
Is it 162 or 163? 163. Yes, that guy. There was a hand up there.
Wait, whoa. I don't understand the Andy of this.
Okay, did you read this?
Both.
So we don't have to read any of those other words?
I just read that whole thing to you. Yes, the other words. Man, seriously, it's like I'm living in the time of Fahrenheit 451 right now. They're like, there's words. Let's burn the books. How dare
I
they?
didn't know that we're doing this.
Words.
Problem.
Ah!
We were
Grab your
talking
pitchfork
about-
and torches.
We were talking about
Words.
examples and
I read that in like 6th grade.
Could it have Earth in Fahrenheit 51?
Fahrenheit 451.
You couldn't.
Do you know why it's called Fahrenheit 451?
Because
Do you-
paper burns.
You know
it
that the
bad.
book has a match, and so you can. Actually
Yes, yeah. It self-ignites at that temperature of 451 degrees.
Both like broken.
Yes, it combusts at that temperature. Anyway,
It's gonna be combustion.
About to go experiment.
basically books are bombs.
so
What?
What? Stop talking.
I'm so lost.
This class special.
True. You get the kids in the back.
Anyway. all right, I think that one was it because it didn't ask for anything specific. It just said throw it into the thing. Throw it in the calculator just to look at the graph. Just to look at the graph. It didn't even give you a question off of it. Now, listen. What if it gave me a t value also? So if I would say 6 seconds, you would tell me something, right? What would you do? Plug in 6 for the t, wouldn't you?
Yes.
Pay attention.
I'm trying. It's just.
It would be like that, and you would get an answer out of it. That's all it is. I'm trying to make this plain as simple. It's super simple.
Yeah, simple.
Super.
You
Just
lost me
plug in the
when-
variable. You log in. I lost your words.
No, you lost me when you go like when you were
Like,
talking something about
about the way.
the method 2, and then you just went on to that.
No. Look.
You like really
No. Okay, look. Don't do this.
Yeah, I know.
You're gonna have a seizure trying to do the math.
Yeah. I know,
Okay.
but, like, you just went
Don't do
to
that.
the other thing.
Don't. You're right. What's my answer supposed to be?
Yeah, 33 over 65.
Is that what we got?
Doesn't
Yeah.
it feel like to have a seizure?
33 over 65, right?
Want to find out?
I was trying to make the point because you need to be able to do these so you can figure them out.
Yeah, I'm good on that.
Okay, I don't want you guys to go and do all this stuff. It is easier to do this because it's stuff we've already done. Yes?
Yeah.
We've already done this stuff. That's the point I'm trying to make. We've done this already.
It's
Alright,
better to
we
do
do-
stuff you know than stuff you don't know.
Yes, I don't want you guys to stress out over stuff, new stuff. You already know how to another way of doing it. Do the other way. Make
we do
sense?
homework now, right?
Yes, please do homework. Please.
Alright.
Please.
No.
No!